In this video, we're going to recap all of the key things we've learned about vertex form and intercept form of a parabola, and looking at how the equation itself can give us a lot of clues to the specific properties of a given parabola. So the first thing I want to do in comparing vertex form and intercept form is do a thinking chart or a T-chart that compares similarities and differences. So the one thing that we know about parabolas that are both in vertex form and intercept form is that they both have the same a value. So the value that you see if an equation is written in this form compared to this one is identical. Vertex form allows you to pull the coordinates of the vertex straight from the equation. They are h and k respectively, and in intercept form we can pull out the intercepts, which are r and s respectively. We do have to be careful though when pulling out those values to be mindful of these negative signs that are in front, and we'll practice that down below. So what I'd like to do is a couple of examples looking at vertex form first, and then we will look at intercept form. So if I were to give you the equation y equals 3/2 times the quantity x minus 4 squared plus 1, what are some things you could tell me about this parabola? So first, if I said to you, what is the stretch or compression factor, you would know to look to A for that. Okay? And so since that is not a value of 1, 3/2 is bigger than 1, we would simply say that it has a stretch of 3/2. It's going to have a more steepy, more narrow curve to it, if you will, than our y equals x squared base parabola. If we look at direction of opening, again, that also comes from the a value. And we can tell if it's an upward facing or happy parabola or a downward facing or sad parabola just by looking at the sign. So since that's positive, we would say that it is upward facing. If we're looking for the axis of symmetry, we know that the axis of symmetry and the vertex have a great relationship with each other in that the vertex lies on the axis of symmetry. So what we could do is we could go to looking at the vertex first. And if we want to pull the vertex coordinates of this particular equation, we can do so by looking here and here. Okay? Now it says x minus 4 overall. What value of h would have it read as x minus 4? Well, if h is positive 4, then x minus positive 4 will give us what we see. So the h value, or the x value of the vertex, is positive 4. The y value of the vertex can be read here from k directly because it has a positive in front of it. So the coordinates of the vertex would be 4, 1. And then because the axis of symmetry and the vertex are connected to each other, the x value of the vertex is also the equation of the axis of symmetry. So x equals 4 would be where the parabola has a mirror image on either side. When it comes to values of x and values of y, we know that all parabolas that we're studying in this unit, whether they be upward facing or downward facing, all have, and I'll use this as the y-axis for now, all have points on their curve that can go on and on and on in this x direction and also in this x direction. So a really fancy way for us to show that, and again, it doesn't matter if it's upward or downward, is that x can be anything. And a really short form way to show it is x is an element of the real number system, meaning it can be anything it wants to be. Now, the y values for a parabola, and perhaps I'm going to begin with just a little sketch of this one first. We know that the vertex is at 4, 1, so I'm going to focus drawing a sketch of this parabola over in the top right quadrant. So over 4, up 1 might look something like this. And I know that it's skinnier or stretched compared to y equals x squared, but I'm just going to draw it something like this. We know that x equals 4, and we know the vertex, as I said, is 4, 1. What can you tell about the y values? Well, if we look at the y values of any of the points that are on this parabola, we notice that the smallest value y can be is 1, and then it can be anything bigger than 1 because it's upward facing. So what we're going to say is that y can be greater than or equal to the value of 1. In other words, it can be bigger than the lowest minimum for that parabola, which happens to have a y value of 1. Okay, let's try this again. This time let's do y equals negative 0.4 times the quantity x plus 3 squared minus 1. Same idea. Let's take from this equation and find out a whole bunch of pieces about it just by looking at it. So for stretch or compression factor, again, we're going to look to the a value out in front here. And we notice that it is negative, which makes it downward, and it is less than 1, which means this parabola compared to y equals x squared is compressed. So I'm a little short on space, but I'm going to say compression factor of 0.4. That's C-O-M-P. I know it's hard to read, but I'll verbalize it too so that you can get what you need from it. There we go. Compression factor of 0.4. Next, it asks us for the axis of symmetry. Well, we realize that it's the same as the x-coordinate of the vertex. Maybe this time we could get it right from here, because we know that h is the value of here. But we have to think about what value of h will give us the sign that's overall. Or think of it that h is the opposite of what you see. So if this is x plus 3, means that h has to be negative 3. And it would mean that the axis of symmetry has to be x equals negative 3. And notice that the axis of symmetry has to be written as an equation, x equals, because it's an entire line, not just a point. All right, what is the y value of the vertex? Well, we know that comes from k. So here we see a negative 1. There it is. What are the values that x can have for this parabola? Well, for all of our parabolas, because we're only studying upward and downward facing ones, x can be anything, where x is an element of the real number system. This is just a Greek letter E to say an element of. Now, this time, this is a downward facing parabola, which means that if we sketch it out, we've got negative 3, negative 1 as a vertex. So let's put it over here in the bottom left quadrant. Negative 3, negative 1 might be something like this. And it's a little more compressed than y equals x squared, where a has a value of 1. So I'm going to make it a little wider. And I'll put the couple features on here. We know that x is negative 3, and we know that the vertex is negative 3, negative 1. So the y values of any point on this parabola have to be less than the maximum value, which is negative 1. So the y values have to be less than or equal to negative 1. All right. So there's a summary of some information you can pull out of vertex form just from looking at the equation. I'd like to do a similar thing now for intercept form. We're going to make a couple of minor changes to the titles just because of what that equation gives us directly by inspection and what it does not. Okay, so let's go to intercept form, and we're going to squeeze in one more column. I'm going to try and squeeze it in over here, I think. Keep the equation here. The stretch or compression factor. The direction of opening. And we're going to add in here x-intercepts. And again, we can add those in because we can get them by inspection. We can't with vertex form. That's why that column wasn't there before. All right, let's try a couple of examples. Let's do y equals 2 times the quantity x minus 5 times the quantity x plus 3. All right. Stretch and compression factor. Again, that comes from the A value. Okay. And here it is. So it's positive, so I know it's upward facing. And it's greater than 1, so that means that this parabola is stretched compared to when A value is 1. So I'm going to say stretch of 2, or a stretch factor of 2. Next, we can find the x-intercepts. And the x-intercepts come from looking in this section of the equation. Now don't forget, in the general formula, they have a negative in front of them. So that means whatever I see, the r and the s values are actually opposite. So my x-intercepts have coordinates of not -5, but 5, 0, and -3, 0. I would not write this as 5, -3. I wouldn't do that because 5, -3 is a single point. It has an x and a y. These are two separate x points, so I have to show them as separate coordinates. Now, the axis of symmetry is always in the middle between our x-intercepts. So we can't get it directly from the equation, but we can average these two or add them and divide by 2. So 5 plus -3 is 2, and 2 divided by 2 means the axis of symmetry has to be a value of 1. That also means that the x value of the vertex has to be a 1. How can I find the y value of the vertex? I'm going to have to go back to the equation, and I'm going to have to sub in x equals 1 here and here to see what the corresponding y value is. Let's see if we can do it in our heads. So 1 minus 5 is -4. 1 plus 3 is 4. -4 times +4 is -16 doubled is -32. And there you go. Now again, even though it's in intercept form, all of the parabolas that we're studying have unlimited x values that can be along the points on the parabola. So x can be an element of the real numbers. Now, this is an upward facing parabola, so all the y values have to be bigger than the minimum. They have to be bigger than -32. So the y values can be bigger than or equal to -32. And if you were to sketch it, you would find that you would have a x-intercept here at -3, you'd have one at 5, and you'd have a vertex down here at 1, -32. And when you do a sketch, you should show all of the key features, all of them. They don't have to be to scale, but they have to be labeled. So we have x equals 1 as the axis of symmetry. We have 1, -32 as the vertex. I'm sorry, I can't read that, but it's 1, -32. We have a 5, 0 for an x-intercept here, and a -3, 0 for an x-intercept here. All things are labeled. Let's go to the final one. Let's do y equals -1/3 times the quantities x minus 4 squared. Now this one is kind of funky because it actually looks like it's in vertex form with a +0 on the end here. Okay? And it would be. But another way to think of this one might be like this. The binomial squared. And in which case it would look like it's in intercept form. And it's important here to note that there are many parabolas for which we can write we can express them as an equation in vertex form and intercept form. But there are some that we can't do intercept form with because they don't cross the axes, and we'll study that in the next unit. All right, let's walk through this. What's the stretch or compression factor? Again, that comes from the A value. Since it's less than 1, we would say it's a compression of 1/3. Let's save the negative to talk about the direction of opening. Because it's negative, we would say it's downward. What are our x-intercepts? Again, those come from this part of the equation right here. But because it's identical, that means there is only one x-intercept. It's at 4, 0. And we'll talk about that when we sketch it over here. If there's only one x-intercept, then that means the axis of symmetry has to also be x equals 4. And because there's only one x-intercept and it's sitting on the x-axis, that means the vertex must also be 4. But what would the value of y be? Well, this is not going to surprise you, but if we put the value of 4 into here, and it doesn't matter which of these, that becomes 0, that becomes 0, that becomes 0. And anything times 0, 0 squared, 0 times -1/3, means the y value is 0. Well, this is kind of cool because it looks like the vertex and the x-intercept are the exact same point. Is that possible? Of course it is. We can have 4, 0 right here. We know that this thing's a little bit compressed, so I'm just going to make it generally wider as a sketch. We know that the axis of symmetry is x equals 4. And because this parabola's vertex is just touching the x-axis, not only is it the x-intercept, it is also the vertex. They are one and the same thing. And that's totally legit. Finishing up. Again, for all of the parabolas that we are studying that are upward or downward, x is an element of the real number system for any of the x values of the coordinates on that curve. In this case, it's upward facing, so the smallest y value you can have is at the minimum, or the vertex has to be 0. Everything else is bigger, so y has to be bigger than or equal to 0. And there you have it. A holistic look at the information you can pull out of equations both in vertex and intercept form, and a little bit of compare and contrast as well.